Welcome back to our series of solution and explanation to competitive coding. So today we are going to solve LeetCode question number 268, that is missing number. Easy one from LeetCode again. So let us understand the question first. Question says that given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. So basically what question is saying, we are given an array that is called as nums. It contains n distinct elements. That means there is no repetition in numbers, that all the elements are distinct, they are different from each other in the range 0 to n, and they are between the range 0 to n. That means they are not out of bound from 0 to n range, they are all from 0 to n range. Return the only number in the range that is missing. So for numbers, for n distinct element, it should be from 1 to n range. Because they are from 0 to n, that means there is at least one number missing, and that is only one number missing because all the numbers are distinct numbers. Okay, so let us see one or two examples. So in this example number 1, we can see if our array nums has three elements, that means they should be from 0 to 3, and we have to spot out what element is missing. And in this we can observe that 2 is missing because 0 is there, 1 is there, and 3 is there. So 2 is missing, we have to return 2. In the second example, it contains 2 elements, that means it should be from 0 to 2, but it contains only 0 and 1, that means 2 is missing, and we have to return 2. In the last example, it contains 9 distinct elements, and they are from range 0 to 9, but the element 8 is missing, and so we have to return that 8. So let's check the constraints. So n equals to nums of len, that means number of elements in the array is denoted by n, or we can use any other variable. So n could be like, length could be between 1 to 10 raised to 4, like there could be only one element in the array, or it could be up to 10 raised to 4. Okay, so nums of I, that is value of those variables, like value at these position should be between 0 to n, whatever the range is, and all the numbers of nums are unique. That means there are no repetition, there is no repetition in the elements. So here comes the follow-up question. Could you implement a solution using only O of 1 extra space complexity and O of n runtime complexity? So let us jump to our explanation board so that we could figure out some solutions. And if you would, suppose this is our array, this is our last from the examples, this one I've chosen. Okay, so suppose this is our example. So what could be the first solution that anyone could thought is, why don't we start checking from 0 to whatever the range n is, all the elements, and check if they are present or not. What I mean to say is that we start from 0 and start looking in the array, start traversing the whole array until we find the 0, and if we find the element, we move on to the next element, that is 1, and we again start checking for the 1 in the whole array, and we found that 1 is also present, and then we go for 2 and we found that 2 is also present, and we keep on going until we found the element, and we keep on going until we found the element that is 8, that is not present in this array, and by traversing whole the array, we find that 8 is not present, and then we have to return 8. Okay, so this is the most brute force solution we could think of, checking all the elements in the whole entire array and in order to find which element is missing. We are sure to get which element is missing, but the problem with this solution is that it consumes O of n squared time complexity, because the follow-up question requires us to solve the same problem in O of n time complexity. So could we do better? Now the problem is, could we do better? That means we could reduce this O of n time complexity to O of something, I would say n time complexity, that are solution demands, I would say, that are follow-up question demands. So now how could we do this better? Suppose here we are given what we can use to reduce this time complexity is the use of separate array. So now let us see how we are going to reduce this. So we are going to take the array of one extra element, and what we are going to do is that whenever we encounter any element in this array, because in Java arrays, when they are initially declared, all the elements are set to 0. So what we are going to do is, whenever we encounter any element in this array, suppose if we encounter 9, we are going to update this 0 to 1 whatever at the ninth position. Okay, so again when we encounter 6, because we have to link the elements in this table and update the element at that position in the array that we have taken, like temporary array. So we encounter 6, we will make again it this one we encounter 4, we'll update this one, and by the end of traversing we could do all these 1 except for 8. 8 will remain 0 and the rest of the element will become 1. And then what we can do is we can traverse the array, and whenever we encounter the 0, what we can do is return that index. So this solution brings us to O of n's time complexity, but the problem again with this solution is that we are again choosing O of n extra space, because the follow-up question asks us to solve this problem in O of n time but O of 1 space, not O of n space. Okay, so now what we can improve to make it O of n time and O of 1 space solution. So third and final approach I would say is using some sort of formula, math formula. We all have learned that sum of first n number is, that is, I can say sum of first n number is denoted by, as we have learned in formula in mathematics, it is denoted by n plus, like n times n plus 1 divided by 2 something. Yeah, it is sure that. So what we are going to do is that we are going to use this formula, n times n plus 1 divided by 2. So what it's going to do is that, because if we are having elements from suppose 0 to 9, so this formula is going to do sum of all the elements from 0 to 9, and what we are going to do is then we are going to subtract the sum of these all elements that are present in array from the value generated by this formula. This formula will give the sum of all the elements from 0 to 9, but what our sum is going to miss the missing value from this sum. So we are going to reduce, or we are going to subtract this sum from this value to get what element is missing. So this solution could bring us to O of n square time complexity and O of 1 space, because we are not using any extra space and we are just traversing this array, like we are traversing this array only once. So why not implement this solution? So let's do this. Okay, so initially we have to create 2 variables, and variable sum to store the sum of all the elements that are present in array, and next variable to store the length of the array, whatever nums.length, to store the length of the array. And now I'm going to traverse my whole array using for loop, and then I can say I is less than n because I've recalculated n, and what I'm to do is update my sum with the values that are present in nums in array. Okay, now what I'm going to do is I'm going to subtract this sum from the range, that is from the value that is given by the formula that computes or calculates whole sum of the all the elements in the range. That means I'm going to return just simply returns, that is I've recalculated n, that means n times n plus 1 by 2. This formula gives sum of all the elements that are present in range 0 to 9, but this sum is holding the sum of all the elements that are present in array, but excluding that element that is missing. So to return that element, we can simply subtract the sum from the sum of all the elements that are present in range. So let me check if it works or not. It seems to work. Let us submit our code to see if it is optimal solution or not. Okay, so it seems to work properly. It is faster, and we have used O of n time complexity and O of 1 space complexity, so it should be fine, and it is faster and use less memory. So that's for now, and if you have a solution, you can comment in the comment section below. And as always, thanks for watching.